Hey guys, today we're going to do a video on completing a square, particularly whenever we have quadratic functions that we want to find the vertex for. And so, our first line, we're going to look at y is equal to x squared plus 4x minus 5. Now, our first order of business is recognizing that our x squared coefficient, which we typically call a, right? You're used the general form of a quadratic formula or a quadratic function written in the form ax squared plus bx plus c. Knowing that a is the x squared coefficient, b is the x coefficient, and c is our constant term at the very end. And so if there's no number explicitly written in front of the x squared, we can imply that that's a 1, and so our a value, our x squared coefficient, a is equal to 1. Okay, that is important, because a being equal to 1 makes our lives easier in that we can jump right into step 2 of our process, and we can write the first two terms, the x squared plus 4x, as a binomial inside a bracket that will all be squared. Okay, and how we'll do that is we'll just take the x by itself, because the square will attach to it later on. And then the second part of the binomial inside of the bracket is going to be half of the b value, half of the x coefficient. And so here, our x coefficient, our b value, is equal to 4. Okay? So then, to figure out what to put inside of this bracket in here, we're going to take half of 4. Half of the value of b. And so clearly half of the value of b is 2, and so we'll have x plus 2 inside of the bracket. Okay? And now we still have the minus 5 from the first line that we still need to take care of. And so we'll write it at the end of our second line. Okay? Now the trick is, this x plus 2 squared bit is not the same as x squared plus 4x, right? This is more than this. And I'll remind you that if we go ahead and expand x plus 2 all squared, we're not just going to get this. We will get this, but we will get x squared plus 4x, but we'll also get plus 4 at the end, right? However, that's not in our first line. And so this plus 4 needs to be balanced out in our second line if we're just going to add it out of nowhere in the binomial squared. And so to balance it out, we'll just do the opposite. We'll subtract 4 afterwards. Okay? Let's do that in black marker. Minus 4. And then to finish it off, now we're going to write it in vertex form or in transformational form. Here we have it in standard form. We want to get into vertex form. And so what we'll have is x, I'll write it as plus 2 in blue marker to make it stand out, squared. And then these two terms at the end are like terms, they're both constants, and so we can combine them. Negative 4 minus 5 brings us to minus 9. And here we have it in vertex form, okay? So this is what we call vertex form. And the coordinates of our vertex, here and here, are given to us by these two numbers here. The only thing we need to remember is we have to switch the sign of the x coefficient. So I'll write that in with the green marker, make it stand out, switch the sign. And so since we have x plus 2 inside the bracket, the x coordinate of our vertex will then be negative 2. However, the y coordinate of the vertex is simply negative 9. So we keep it the same, and we find our vertex for this quadratic function at negative 2 and negative 9. And that's it. Okay? Now, this is, I would say, the quickest way to find the vertex, certainly when we have an a value of 1. We're going to see an example 2 of the slightly trickier case when the a value is not 1. But another way we can do it is we know that quadratic functions are always symmetrical about the vertex. And so our vertex is clearly at negative 2, negative 9. We could have also gotten the roots by factoring this quadratic and then finding the vertex in the middle of the two roots. But we'll save that for another day. Okay? So let's move on to example 2 and see how this works out when the a value is not equal to 1. Okay? And so in this example, we'll know that a is equal to negative 2. Right? A being the x squared coefficient is not 1, but namely it is negative 2. Okay? So So the first thing we need to do is factor the negative 2 out of the first two terms, okay? So if we do that, we can write negative 2, and then we can start our bracket that will eventually square at the end, okay? But we're not going to square it quite yet. We're just going to write the first two terms as they are with the negative 2 factor. And so we'll have negative 2 times x squared, and then negative 2 factored out of negative 10x will be plus 5x, because negative 2 times positive 5x would give us negative 10x back, okay? And then at the end, we'll still have our minus 12 because we only factored the negative 2 out of the first two terms. So the minus 12 can stay as it is at the very end, okay? Now we have the negative 2 factored out. Now we can go ahead and with the binomial inside of a bracket, we can go ahead and write it as the square of a simpler binomial. And so we'll again take half of the b value. So here b was equal to 4 because we had plus 4x, and so we took half of 4, which was 2. Here, our b value is equal to 5, and so if we want half of that, half of b being 5, then we're going to write this as x plus, you can write it as 5 over 2. You can write it as 2.5 if you'd rather work with decimals. I'm going to leave it as 5 over 2. And now we square the whole thing, okay? And we have minus 12 in the previous line, and so we still need it in this line as well, okay? Now here comes the tricky part. In our first example, when we changed from x squared plus 4x to x plus 2 all squared, expanding it over here showed us that we gained a plus 4 from it. And so to balance that out, we subtracted 4 over here, okay? Now we have to do something similar in this case, but now we're not only going to get a 5 over 2 squared, right? You might notice that the 4, the plus 4, is simply a result of having 2 squared, right? That positive 2 squared. And so if we do the same kind of thing over here, 5 over 2 squared, I'll remind you, 5 over 2 squared is 25 fourths. But that 25 fourths, we can't just subtract it because it's being multiplied out front by the negative 2 that we factored out at the very beginning, okay? So we can go through that. If we multiply 25 fourths by that negative 2 times 25 fourths, we can simplify this down. The 2 over the 4 can simplify down to 1 over 2. And so we'll end up with negative 25 over 2. Negative 25 over 2. That's what we gained out of writing this like this. And so to balance out this out of thin air negative 25 halves, we have to do the opposite and add 25 halves. Okay? So now we can continue. We still have negative 2 bracket x plus 5 halves all squared. And now we can combine these two terms. There are different ways to do it. If we want to write this as a mixed fraction and leave that as a whole number, we can do that. That'll work out nicely. 25 halves written as a mixed fraction will be 12 and a half. And then we're still subtracting 12 at the very end. And finally, to simplify it down to its vertex form, we'll have negative 2 bracket x plus 5 halves all squared, and then 12 and a half minus 12 clearly is 1 half. Okay, and so again, this is our vertex form. This is in vertex form. And the reason being is because we can readily read off the coordinates of our vertex, which is what we were after all along. Again, we switch the sign for the x coordinate. And so in this example, we had x plus 2, and so our x coordinate for the vertex was negative 2. We're going to do the same thing in this case. We have x plus 5 over 2 in the function, and so the x coordinate of our vertex will be at negative 5 over 2. And the y coordinate was the same number as we had at the final step of this process. And so the -9 shown here becomes the y coordinate of the vertex. And so we have 1/2 at the very end here. And so likewise, it'll become the y coordinate of our vertex. And so our vertex for our second function is found at -5/2 and 1/2, okay? So again, if we wanted to find this vertex a different way, we could have factored it usually. We could have found the two roots and then found the vertex right in between the two roots. Again, by the argument that quadratic functions, parabolas, are symmetrical about the vertex. But again, we can do different video on that. So I hope this helps. I hope this kind of breaks down the process of completing the square, when we can go ahead with our squaring of the first two terms right away, and when we have to factor out the a value whenever it's not 1. And if you guys have any questions, comments, suggestions, please let me know. If any requests for future videos come up, please comment them down below. And thanks for watching.